Okay. How about now? Is this working?
We can't see your note screen. Go ahead and start drawing. Let's see.
There we go.
We're good.
Great success.
Okay. So let's begin. It turns out that all number systems are actually really similar. So consider this. If I write that, can somebody come off of mute and just say, what do you see here?
Numbers.
Numbers, what are they, Zaria?
Wait, what do you mean?
What do you see? If you had to tell someone what you're seeing right now to take notes, what would they write down?
Numbers?
What number?
1, 2,
One,
and 3?
right? Is there another way that I could interpret this set of numbers besides 1, 2, 3? What other way might you represent these numbers?
Single numbers, whole numbers.
Okay. Specifically, we could see this as 100 and
Oh,
right?
3, yeah.
Zaria. So
Yeah.
we're getting there. We're getting there. So I could see this as 1, 2, 3, but more specifically, I'm reading this as 123, and that's not by accident. It's because this guy here, this is in the ones place. This guy you learned back in kindergarten, this is the tens place, and this one is in the hundreds place. So really, we're doing some math in our head really quickly. We're doing 100, we're adding to it 2 tens, and then finally 3 ones. So 1 times 100 is 100, 2 times 10 is 20, 3 times 1 is 3, and adding them all together we get 123. And so we're going to apply this same process to binary, but instead of our numbers places being ones, tens, and hundreds, hint, we're moving from a decimal system to a binary system. What might our places be instead of ones, tens, and hundreds? Anybody? Well, in binary, we're going to have ones, twos, we'll have the fours place. After that, we're going to have the eights place, then the 16s place, and so on and so on. What do you notice? I'm multiplying every place by 2. Well, that's familiar. Over here, we multiplied every place by 10. So in binary, we have a new way of representing our numbers. So write this down, please. If I wanted to represent the number 1, actually, if I want to represent the number 0, let's start there. Can I have 3 placeholders or 3 bits? Okay, then that would just be 0, standard. If I wanted to represent the number 1, I would put a 1 in the ones place. Can anybody want to take a shot? How might I represent the number 2? Be brave, come off mute. Yeah, go ahead, Jalen.
I think you want to basically put it in the one place.
Could you just speak a little bit louder? I can't really hear you.
I think you want to put it in the one place.
So I'm going to put, so this is 1. So what would I write down? 0 what? To represent the number 2.
Write down 2.
Right here? Or would I put it over here?
Yeah.
Okay, who can tell me what's wrong with this?
I think I see.
How many digits do we have in binary? We only have 2 digits. What are those digits? 0 and 1. So Jalen, the issue is the number 2 doesn't exist, right? The number 2 does not exist. So how might we represent the number 2 in decimal but in binary? Anybody else want to take a shot? Go ahead and come off mute because I can't see everybody.
Would it be 0, 1, 0?
Who said that?
Peyton.
8. How do you say it?
Peyton.
Oh, Peyton. Yes, you're right, Peyton. Exactly. 0, 1, 0. How did Peyton get that? He recognized that we have a 0 in the ones place. We have a 1 in the twos place. And then we got nothing in the fours place. So if I add this up, I have a 1 in the twos place, then I just have 1, 2. If I want to represent the number 3, I just need to add on a 1. So it would be 0, 1, 1. This is not 11. This is the number 3. again, a 1 in the ones place and then a 1 in the twos place, adding them together, I'll get 3. So we could go on and on like forever, really. But I want to get to something a little bit more interesting. So if you could please direct your attention to, let's see if I can switch the screen that I'm sharing. Options. I want to stop that sharing, and now I want to share my own screen. Okay. So this is a fun little way that we can show how binary works. Basically, I have each spot here, each light bulb represents a different bit. So if I start counting, watch what happens. Okay, watch really carefully. That's the number 1, right? If I put a 1 in the twos place, like Peyton said, that's the number 2. Adding the 1, I get 3. Look what happens when I go to 4. These 2 guys on the right went blank. They became zeros. And then I got that 1 to roll over to the number 4, which is really similar if you think about our number system. If I want to go from 99 to 100, those last 2 9s roll over to become zeros, and I put a 1 in the hundreds place. I'll show you what I mean. If that was confusing, I'll explain it in a second. You'll see some more. So this is 5, 6, 7, rolls over to 8, 9, 10, 11, 12, 13, 14, 15. What's going to happen now? How will I represent the number 16? It's going to roll over to the 16th place. I get 1, 0, 0, 0, 0, 17, 18, 19. And we could do this all day. Is it starting to make a little bit of sense? I hope that the visual is helpful. Nod your head if like, okay, I'm starting to see this binary stuff. Okay, so I'm gonna ask that Medellin, Ashley, Alex, Jessica, Gabriel, is it Danny, everybody come off of your hidden camera. I would like to see your faces. That's part of being in this class. 30, I don't even know, 49, 48. Ugh. Okay, so it's getting fast quick, but I'm going to pause it. Now I'm asking for a volunteer. I would like some brave soul to come off of mute, and try representing a number. Do I have a volunteer? And I understand that we all learned this exactly 2 minutes ago, so it's okay to make mistakes. This is part of the learning process. How about Angela or Mia? Would you mind volunteering?
Yeah.
Awesome. So here's your challenge, Mia. Ready? Your challenge is to represent the number 20. How would you represent the number 20? Tell me which bulbs to turn on.
4 and 16.
16, and then 4 more gives me 20. Nicely done. Let's try another one, Mia. This time, let's try 23. How would you get 23?
16. 4.
So far, we have 20.
2 and 1.
2 and 1. Adding them together, 16 plus 4 is 20, plus 2 plus 1 gives me 23. So if I were to represent this in binary, I can ignore these guys on the left, but whoops, I would have a 1 here, 0, 1, 1, 1 gives me the number 23. Can we get some snaps from Mia? Nicely done. Okay, so coming back to our slides, let's move forward in our lesson. Okay, so some time ago, people decided, hey, representing numbers is pretty cool, but we want to do more than just that. So it would be nice if computers were not just calculators, but also could do things like word processing or email or other modern incarnations of technologies that we use today. So the world decided arbitrarily, completely arbitrarily, as in there's no reason for it, but at least universally, that if you want to represent the capital letter A, that the numbers used to represent it, the pattern of zeros and ones, would ultimately be the decimal number 65. We'll just all agree on that. And if you want to represent the capital letter B, you're going to use the patterns of zeros and ones that give me 66, and so on. And so I can actually send a message now let's pretend that I represented you a message that was 72, 73, and 33. Can anybody guess what this might represent? Well, let me go back so you can see. What would 72, 73, and 33 maybe be? This is your invitation to come off of mute for a second.
Jalen, you can just come off of mute instead of raising your hand. Just take over. Just do it.
Take over.
Letters.
What would it be?
Letters.
Letters. What letters? If we go back. H?
Yeah, H. I don't know the other ones.
I? Any guesses for the last one?
Nah, I didn't even see it. Just too quick for my eyes.
It wasn't shown, but it's actually an exclamation point. So that patterns of zeros and ones would represent the word hi with an exclamation point. So I can do more than just word processing though. If I say, so in computer science, we have something called the RGB value, or red, green, blue. So I can say, hey, if 72, 73, and 33, instead of representing letters, actually represented colors, then I could say with this, hey, give me that much of red, that much green, and just a little bit of blue, meld them all together, and they would actually produce this like murky green color. And by putting these together and now getting what you have on your screen is a pixel, you'll notice that if I put a bunch of pixels side by side on a computer screen, then I can actually come up with an image. And notice that every pixel, this is from Wikipedia, this is Google, every pixel is really made up of just a little bit of red, green, and blue. And indeed, the color white, if you see white on your screen, it's all red, all green, all blue. So that means that all of them are turned on to full blast to create the color white, because that's how light works. If all the colors are going, then you have white light. So then I can do this. Instead of having a bunch of pixels on a screen making an image, now I can do image after image after image, and now I can create motion picture. And hence you have Netflix and Hulu and YouTube galore. So keep in mind that actually we started out with this on the right, with binary, just zeros and ones. But we know that to send a text message, it's really just a bunch of numbers. And those numbers are really shown in your computer through zeros and ones only. And so we're introducing to you today the idea of abstraction. And abstraction means that we don't have to think about this layer here at all when we send a text message. We can abstract that away and just send our text message. How's it going? And so abstraction means, you can write this down, taking away non-essential details and just leaving a simplified representation of something more complex. So again, when we're abstracting layers and layers and layers, we go from the lowest layer, which if you're watching my hand is binary, and then that maps onto letter or numbers from there, and then that maps onto letters, or it could be colors, which then goes to images and videos and so on. So abstraction is really at the heart of everything that we do in computer science. So remember, for abstraction, in order to create all these very complex processes that we're seeing on our computers right now, indeed this Zoom call you're on at the moment, we really started with zeros and ones. And so when we talk about the inputs and the outputs, really the inputs to our computer is just zeros and ones. The outputs are what we're seeing on our screen. And what's inside this box? We'll cover that in a future lesson. But for today's purposes, I do want you to know, okay, so I get how ASCII, by the way, I never mentioned this before and it's actually really important, but could you please write down this word here, ASCII, A-S-C-I-I, which stands for the American Standard Code. So I'll say it slowly. The American Standard Code for Information Interchange. All you need to know is that it's ASCII. By the way, I'm sending out a reference sheet of notes in case you weren't getting down everything from today's lecture, so you don't have to freak out, but definitely be taking notes for yourself. But things like what this stands for will be on that reference sheet. And so remember, ASCII is what maps numbers to letters so that we can type messages to each other. So it's the thing that says A is 65, B is 66, and that the exclamation point is the number 33. That's what ASCII is. Okay, so again, for today's lesson, we really just want to focus on practicing our number conversion using binary, and something that you'll come to learn is called hexadecimal. So write down skill number 1. On your paper, you should be writing the word skill number 1. And copy this down. It's going to take me just a minute to get set up here. I need to chat. Lindsay, just so you know, I'm chatting myself the link for the slides.
Okay.
And so I can annotate. Okay, by the way, if anybody has any questions right now, feel free to ask. Maybe we could do a practice problem. Here, let me just go to the next slide. Okay, so that's going to be our practice problem. I'm given this number in binary, so write down example 1, binary, and I want to convert to a decimal number. I want to see what that represents. Go ahead and try that problem yourself. Whoops, I went to the wrong slide. There, try that number yourself right now, and in exactly 90 seconds, we are going to get started together. Yes, in the chat, someone said American Standard Code. It's American Standard Code for Information Interchange. Okay. So did anybody come up with an answer? If so, type it in the chat, but wait. I'm going to give you 10 seconds to think. Hit enter when I say go. So those of you who came up with an answer, type it in, but don't press enter yet. Ready, set, go. So we got a 19, we got an 18 question mark. And Lindsay, can you tell us what's the right answer?
Sorry. I don't think I can. You put me on the spot there. I was switching over to Canvas.
Like a lot of us got 19 and then some of us got 18. Do you guys see my screen right now? That the one that I am writing on?
No.
No.
We're seeing the slides.
Let me try. Yes.
Yes.
Should have switched now. Okay.
Oh.
Yes.
Oh.
So here's what we're going to do. Let's do this problem together. The first thing I want you to do is memorize these numbers that are shown. So right here, I want you to write 8 slots. 1, 2, 3, space them out. 4, 5, 6, 7, 8. Underneath each of them, you should write these numbers because these are the place values. So we're going to put the 1's place, do it with me, the 2's, the 4's, the 8's, 16, 32, 64, and 128. In fact, I'm going to give you 30 seconds right now to memorize this pattern of numbers. 1, 2, 4, 8, 16, 32, 64, 128. One, 2, 4, 8, 16, 32, 64, and 128. Okay, so our first step is to fill in the 1's and the 0's, and we're gonna start on the right side. So we have a 1 here in the 1's place, a 1 in the 2's place, there's 2 0's, and then there's a 1. That means that everything else is just zeros. but we don't have to even write them down. We don't need to think about them. Just like if I said, hey, what's this number? You would say 99. Why are you writing the extra 0 on the left? Okay. So we can focus here. So I have a 16, a 1 in the 16s place, and then I have a 1 in the 2s place. So I'm going to add them, and a 1 in the 1s place. So my final answer is 19, and we did it. That was my decimal. Good job to everybody who got it. Let's try another problem. Okay, so this one's a little bit longer. Do it the same way that we did before. So write down your numbers at the bottom. So since you don't want to actually, okay, follow my lead on this one. Copy this down with the numbers spaced out, like 0. Whoops. So copy down those numbers spaced out like this. If I was a student, I would go like this, 0. Oh, it's not writing. This is un problem. Okay, I can do this.
I think you're on the eraser, Mark.
Oh,
okay.
Thank you, Ms. Matsuchi. I will try that on the next one. Let's see if this is gonna work. You said eraser mark? Where would that be?
Looks like it's on the bottom right.
Yeah. Oh my gosh, look at us figuring out how to use technology. Okay, wonderful. So I would write it down like this if I was a student. 0, 1, 0, 0, 1, 1, 1, 0. Spaced out like that. Then underline them all and fill in the place values. So starting on the right side, we have a 1's place, the 2's place, the 4's, the 8's, 16, 32, 64, and 128. So again, the process is super simple. To get our decimal number, just add up anything that has a 1 there. So we got 64 plus 8 plus 4 plus 2. Did I get that? Those of you who got a final answer, what did you get? Equals 92. And if I hear no objections, then 92 it is. So this gives me 10, 4, yes, wait, 10.
It's not 92.
98 actually.
It's 80.
It's 80, like 64 plus 8 is 72 plus 6. Oh my gosh, guys, our math is all over the place today.
Oh, it's 78.
Is it 78?
I was about to say, like, wait, am I counting wrong?
Yes.
We
Give me a
cannot
thumbs up.
add today.
78. Awesome. Let's move on to the next example. Okay, now we're going to go backwards, and it's a little bit trickier when we're going backwards. This time I'm going to give you the decimal number. Oh my gosh, I'm going the wrong way. Okay, this time I'm going to give you the decimal number 77, and I'm asking you to convert it to zeros and ones. So let's see how that'll work out. Sorry about that. I'm going to take that to my notability. So please copy down the steps that you see. What is happening? Import. Okay, please write down the steps that you see here. Which you can't see any steps because I'm working on this. Okay, there they are. So step 1. So what you should write on your paper right now is this, decimal to binary. So now we're going backwards. Here are the steps. Step 1, put a 1 over the biggest number that fits. So to demonstrate, if I want the number 77, then the biggest number out of these that fits into 77 is going to be 64. So on your paper, let's go ahead and always draw 8 placeholders like that. What I'm doing in red, you should be doing on your paper. Underneath, write the 1, 2, 4, 8, 16, 32, 64. You're going to do this every time. And now we're going to put a 1 over the biggest number that fits. So the biggest number that fits is going to be a 64. I don't want to put a 1 in the 128's place because now the smallest number I can represent is 128. But I only want 77. So a 1 goes here. Okay, step 2. We're going to subtract that number from the total. So on the side, I'll do 77 minus 64 to see how much more I need to add on. Subtracting, I see I need 13 more. Well, how will I make 13? I will repeat. I'm gonna put a 1 in the biggest number that fits inside of 13. The biggest number is, well, 16 is too big. That will be greater than what I want. So 8 is the biggest number that fits inside of 13 without going over. So now what do I do? Well, just like before, let's see how much we have left. So we're gonna subtract 8 from that, leaving us now with 5. So what's the biggest number that fits inside of 5 without going over? It's 4. How much further do I need to go? I'll subtract, and I can see that I only need 1 more, bringing me, if I did my math right, to a total of 77. So steps 1 and 2, we're gonna do over and over. And then finally, our last step, we'll put 0 in the empty spaces. And you can actually check this. 64 plus 8 plus 4 plus 1 does indeed give me 77. So our final answer is right here, 0, 1, 0, 0, 1, 1, 0, 1. One of these numbers I don't have to write down on my paper. Which one is it? Which number is it okay if you leave it off? Anyone?
The first 0.
Yeah, this first 0, exactly. I don't need to write that. So my final answer could be 1, 0, 0, 1, 1, 0, 1. And we're done. Okay. Coming back, let's try another one. So please try this one yourself. The decimal number is 14. Please write it down. The decimal number now is 14. You're taking the number 14 and you want to convert it to decimal. I mean to binary. Okay, take 10 more seconds. Now I'm gonna work it out. If you get your answer before me, put it in the chat so you can compare. All right, so 14. So first I'm drawing my 8 lines. Then I'm putting 1, 2, 4, 8, 16, 32, 64, and 128. So step 1, we want to put a 1 in the biggest number that fits inside without going over. In this case, that would be incorrect. Now 16 is the smallest number I can represent. So we want to put a 1 here in the 8's place. 14 minus 8 leaves me with 6. I need 6 more. What's the biggest number that fits into 6 without going over? It's going to be 4 this time. Subtracting the 4 tells me I just need 2 more. So I'm going to put a 1 in the 2's place. And if I subtract, you can see I'm at 0 now. We're good to go. So the number is 110, 1110. There. Let's see how many people got it in the chat before me. Several. Very, very good job. All right. Let's try another one. Okay, this time try doing the number 15. I'm not going to help you. Come off of mute when you have an answer and tell me how you got it.
Alexander got it.
Okay,
Maria got it.
Can you come off of mute, please, and tell us how you got your answer? And I'm just going to write.
You just add another 1 to at the right, all the way to the right.
So we had 1110 being 14. So to get to 15, you just needed to add the 1. That's what Alexander said. And indeed, that is the number that represents 15. We just need to add 1 more. So here's my question now. Change that. By the way, good job. 1111 was the answer. Now we're going to change it to 16. Somebody different come off of mute and tell me, how would you change from 15 to 16? What change do I need to make here?
You put the 1 on 16 and change those ones into zeros.
So put the 1 on the 16 and then change these guys to zeros. Good job, Maria. Exactly. So I'm going to roll over the 1 and all these guys become zeros and I have a 16. And if I wanted 17, I'd put a 1 here and so on. Good job. Okay, let's see what we can do next. How do I get out of here? Okay, I'm going to try this instead. Share screen. So if you haven't already, take a minute and memorize, like I said, these numbers at the bottom, down there. Highlight them on your notebook, make sure you get to them. And now I have a question for everyone. So let's see who's been paying attention. If I told you that this binary number represented 13 and that this binary number represented 44, who can come off of mute right now and tell me how you know there's a mistake without doing any math? How do you know that there's a mistake without doing any math? This is a tricky one. I'll give you a little time to think. So I see Maria is off of mute, Peyton is off of mute. Let's give people like 20 more seconds to think about it. Then I'll call someone who's not muted. So I'm telling you that these are both wrong. Think with me without doing math, just by looking at one thing. How do I know that I have a mistake? Let's hear from Peyton.
For the first one, the ones are in the 8 and the 4's place, so that would be 12, but not 13.
Okay, so you did a little bit of math. I want even less math. You're correct. That's 12, not 13. How could I know that this is wrong? But also, Peyton, you have to apply the same logic to the second one. So I want one rule without adding any numbers that could tell me both of these are wrong. Let's hear from Maria. Did you have a different answer?
Okay, so the binary numbers can't have zeros in front. I'm not sure.
These zeros here? Yeah, those zeros could be gone, but I would still have the wrong number. So it's not about these zeros in front. Those zeros don't make a difference.
Ashley got an answer.
Okay, can you come off of mute, Ashley, because I can't see. What did she say?
The ones isn't odd. I mean, hold up.
You're on the right track.
Then the value has to be an odd too.
So say that one more time.
If the ones position has a 1, then the value has to be an odd.
Thank you. Exactly.
Beautiful.
Let me rephrase what Ashley said. She said, if there's a 1, now watch my cursor. If there's a 1 in the ones place, think about it. Aren't all these numbers even? 2, 4, 8, 16, 32, right? They're all even numbers. The only way I can get an odd number is by adding a 1 at the end, putting a 1 in the ones place. But check it out. This guy has a 0 in the ones place. So mustn't it be an even number then? But I'm saying it's 13. That's odd. But this says it's even. So I know there's a mistake. Let's look at the second example. Looking here, do you guys see the 1 in the ones place? Does that make this number even or odd? Well, there's a 1 in the ones place. So that means it must be odd, because anything, if you add any even number, if you add 1 to it, it becomes odd. But I'm saying it's an even number, so I know that there's a mistake there too. So that's a really fun, interesting little trick you can use to figure out if you're getting these right. So here's our first ever, oh my God, so exciting, first ever AP exam question. Okay, this is a real question from a couple years ago. And it says, ASCII is a character encoding scheme that uses 7 bits to represent each character. The decimal, or base, our number system. Alexa, stop. Sorry, that was Alexa, she's weird. Okay. The decimal value 65 through 90 represent the capital letters A through Z. We learned that. So here's my question. What ASCII character is represented by the binary number 1001010? I'll give you guys 60 seconds to work this out. I should see everybody working on their paper. Remember, our strategy is to write these out with spaces, underline each one, and put their place values underneath. So the 1's place, the 2's place, and I won't say anything else. 60 seconds on the clock. And don't type your answer in until I say go. Mr. Diego, while they're working, I want to just tell you that I'm going to go right now to my meeting. So could you go over the next 2 slides, which are vocabulary terms, and then just leave it at do hexadecimal another day. And then, yes, so do the next 2 slides. And then if you could go down to slide 55, it's an overview of what their homework is. Okay, actually I need to change those slides. So, and then if you have the digital flippy do, Mr. Hang, could you grab the link for that? Because I haven't put it anywhere. Could you put the digital flippy do in the app so that Diego can start going over the homework with anybody who wants to do problems together? Okay, ready? Let's see if we got it. Set, go. Type your answer into the chat. Let's see what we got. What are the answers that we're seeing, y'all?
J, H, I.
Got J, H, and I. Let's see what the right answer is in this case. Whoops. Okay.
J.
The right answer is J. So yes, the right answer is J. And if you're curious to see how that works, you can stay on. Mr. Diego is going to continue the next 2 slides. So make sure, Mr. Diego, that you can share your screen.
Let me do that right now.
I can actually show right now.
Go ahead.
Students can start. So these are the terms that you should take down for today.
All right.
Can you guys see my screen?
Yes.
Perfect. So as we've been covering binary digits. So if we break it down into smaller pieces, the lowest or the smallest piece that we can get is a bit, which is a 0 or 1. Now, if we start grouping them into the four bits that we have, you start getting something which is a little cute. They call that a nibble. So you have the four positions. So those it's called a nibble. And then if you start encapsulating all the way up to, I believe it's the 8 positions, that's when you have the byte, commonly known as a byte. So you have your bit, which is 0 or 1, 0 or 1, and then you have the 4 positions, which can be represented as a nibble, and then finally you have a byte, which are the 8 bits. Moving on to the next slide. So we've been covering the binary system. We also just covered the unary system with the whole slashes. But we also have another system called the hexadecimal. Now, this is all different types of bases. So our 0 through 9, the 10 digits, this is something called base 10. Now, for binary, can anyone guess what base that is? Hint, hint is on the screen. Anyone want to provide the answer? Don't be shy.
Peyton, you can't
Peyton,
talk.
can you unmute?
Okay, base 2.
Exactly. So it's base 2. Now, what does base 2 mean? That you can either have a 0 or 1. And just like we have for base 10, for we're typically counting like 0, 1, 2, 3, that means you can have 10 digits to represent. That's base 10. And hexadecimal, as we'll cover in our next lecture, will be base 16, meaning that you can represent a value with six digits. But this will only be digits, it'll be also including letters, so A through F, as you see in the slide. that's what we're going to cover today. Let's go ahead and hop into the homework assignment that we want to cover. So today we want to make sure that we are going to cover the skill number 1 in Canvas. So if we go to our Canvas and we go to our skills, let's make sure we get that. Tang, do we know?
It's on
Go ahead.
module 1.
Okay.
Mm-hmm.
Do we know if we were able to get the whole password situated for the check-in?
No, not really.
Okay.
Because the form is controlled by Miss Name.
Got it. Okay. So if you weren't able to mark down your attendance on the Canvas, it's okay. Don't stress about it. We'll try to figure that out.
We will change the password on the slide, so if you guys check it out later, we'll get the right answer.
Exactly. So as Tang was mentioning, in Canvas, skill number 1 is in modules. Please do that. And also the homework, the Penguin binary game.
So
now this one I was looking for.
So this homework, you guys need to do this until you score 120, I think.
So if we open up this link, do you guys see my screen when I switch tabs, or is it only still the slide? So I'm switching now. Can you see my new screen?
We can see it.
Okay. So the link is provided. Once you click on the link, please go ahead and start playing with that game. Try to get more practice. Okay. I'll be on until 9:30. If anyone has any questions, feel free to ask me. Lindsay, if you have to go, please do me a favor and just make
I'll
me a
make you
host.
the host. Yeah.
Yeah.
Tang and Diego, do you need anything before I head out?
I'm good. Thanks.
Okay, then I'll see you all on Friday and everybody else next week for the rest of the classes.
Oh yeah, Wednesday is a holiday, right?
I think it's ACT prep.
Yeah. Okay.
Yes, I am back. Are there any questions? Really quick, some of you just made a copy of our homework assignment. Awesome job. I, however, did make a couple of last minute changes since we did not learn hexadecimal today. If you make a copy now, the homework is accurate. So part 1 is going to ask you to, can I be patent? Yes, I can. So let me just share my screen really fast. I know you guys have a class to go to at 9 a.m. So we're going to finish up in the next minute or so. Hopefully you can see my screen. But part 1, you're going to play this game here, which you saw the image of. Paste a screenshot of your highest score, minimum score of 150. Then you're going to come to part 2, do some practice. Let me make it very clear from now that you must show your work on a sheet of paper. And at the very end of these questions, you are going to paste a photo of your work. This whole assignment shouldn't take more than, for this part, like 20 minutes, I would say. If you're struggling, maybe 30 minutes. And then finally, part 3, you're just gonna answer a couple of reflection questions. Please use full sentences. You guys are doing great in the Piazza. Today, we'll just write our reflections in this document just to keep it all in one place.
Ms. Name, just to confirm, the Penji game, we just want to use it just to practice. Is there anything they need to submit after completing the game?
After you play the game, you should paste this screenshot. Take a screenshot that you've achieved a minimum score of 150. And if you get the highest score in the whole class, then we have a reward.
All right, thank you for clarifying.
You're welcome. Okay. Do you want to preview the digital flippy-do for anybody who's interested?
I definitely can. Let me just get that up. One moment.
I'll explain. So for those of you who are like, whoa, today's lesson was way too fast. I just need something to help me figure this out. We have a tool for you. It is called the digital flippy-do, and it helps you work through the binary problems. So if you feel confident with today's class, you are totally free to go. And if you feel like you want a demo of how the flippy-do works, Mr. Diego, give me a thumbs up if you're getting it.
All right, so I have it now.
Awesome. We'll put a link for this in the Canvas too.
Sure. So if you need additional practice, we could do this on paper as well, but this is just going to be on slides. It's a little bit more convenient. But the concept is pretty straightforward. What you do is that you have these positions, right? As Ms. Name was explaining earlier, our strategy when we're going to solve our problems is that we're going to fill out the positions of the values. And what we're doing is we're dragging these little cards, these cards with zeros or ones. And whenever you want more practice, just go ahead and just drag the card into the respective position, the 0 or 1, and then just test yourself. Just come up with a number in your head, say 77, and how would I represent 77? I would drag over a 1 into the 64, and then I would drag what else? Maybe a 1 into, let's say, the 8. That would give me 72, I believe. And then I would draw a 1 to the 4, and then ultimately I drag a 1 to the 1 position. So this is additional practice that allows us to just reinforce our understanding of the binary system.
Diego, I just wanted to mention that the first 2 slides of the flippy-do are demonstrations how to use it. So you can see right now that they created the number 36. If you show them the next slide, go to the second slide. I think it's still on the first.
Still on first slide.
But you guys.
I'm sure. Oh, I'm talking about the wrong. I've got apparently the 2 tabs open of the same content. My bad.
You can see what you were talking about, but this one's going backwards. You guys can look at the first 2 slides to get information, and then the last one is what you'll actually use if you're using it for your homework. All right, y'all. You're good. Go crush it in your next class. What's your next class? Am I saying that right? Bye, everybody.
Bye.
Thanks, everybody.
The password still not work for some people.
I may have identified what the issue is
Mm-hmm.
with the password. So in Canvas, it's loading the attendance check for sync block 1. And in the spreadsheet, this class is in sync block 0. And there's a different form for that. And so I think that's why the password's not working, because it's for a different form. I took a screenshot of everyone who is here today in the participants list, though, if that's helpful.
Actually, Miss Matsuchi took manual attendance.
Oh, okay. Got it.
So we're good to go.
Okay, cool.
Yes. All right. Cool. So yes, 9 o'clock, everyone's gone. This is what we can expect. Okay.
Okay.
Team, any reflections? How did that go, etc.? Before we.
Oh, they're all gone. Okay.
So they have a class.
Yes.
I wish I had learned binary this way.
Oh yeah.
I'm sorry I failed your cold call, Lizzie. I felt so bad. I was looking at Campus and I'm like, cool, getting ahead. And I heard my name and then I was like, I'm so sorry. I can't hear you. Sorry.
Oh, I was saying that's what you should be doing, is looking at Canvas and getting ahead. I feel bad because I was using you to fill time for myself.
Oh, no, that's fine. It was a really good moment though. I was like, wait, I don't even know what we're doing. And then I felt bad, so I apologize.
Recording, by the way.
Oh yeah, I'll stop recording.